We'll now do numbers 11 and 12 of the Chapter 2 test review. Number 11 is already set up nicely in work form. So we'll go ahead and graph right from there. As a reminder, this -2 changes the steepness, and we know it will be flipped. Now we'll just work with this later, but at least we have an idea of what it will look like. What's inside the parentheses, this moves it left 4, and then this 1 moves it up 1. The reason it's left 4, it's the value that makes the squared part 0, and that would be -4, so we would move left 4. So we know the vertex will be left 4 and up 1. So let's go ahead and put the vertex there. We know it's going to be a little steeper and pointing down. The way that we can be more specific about this is choose some points close to the -4. So let's try -3 and -2. Maybe we'll try -1, but I'm not sure it will fit on the graph. So I'm going to just talk through this, putting -3 in for x. -3 plus 4 is 1. 1 squared is still 1. Times -2 is -2. Plus 1 is -1. So when we get plug in -3, we get -1. Nice thing about parabolas, they are symmetric on this vertical line here, so we will have another point over here. Plugging in -2. -2 plus 4 is 2. 2 squared is 4. 4 times 2 is -8 plus 1 is -7. So at -2, -7, we have a point, which means over here we'll also have a point. Putting -1 in isn't going to be that helpful. I'll talk through it. This would be -1 plus 4 is 3. Squared is 9. Times -2 is -18 plus 1 is -17. Won't fit on our graph here. We can now graph this though. Sometimes I have a rough time with graphing these on here, so let's give it a try. Yep. Could have been a little bit better, but you get the idea of what that should look like. For number 12, this is not in work form, so we'll need to complete the square. Now, if you do have trouble, you could always make a table, plug in a lot of points, and figure out where the points are on the graph, and that will also work. Probably just be a little more tedious, but it does work. But the way I recommend is completing the square to help put this in work form. So the first thing, complete the square. If there's a coefficient other than 1 here, you need to factor it out of the first 2 terms. And so we're going to factor a 3 out, just the 3, not the x. So 3x squared plus factoring 3 out of this gives us 4x. We're going to leave a gap, and then we have plus 8. Now what we do, we want to complete the square by taking half of 4 and squaring it. So half of 4 is 2, so plus 2 squared. We just added 4 inside these parentheses, but anything inside the parentheses is multiplied by this number out here. So we actually added 12. We can't just add 12 to an equation. We can either, so we added 12 to this side, we could add 12 over here, or we could subtract 12, because if we add 12 then subtract 12, we're adding a grand total of 0. So now we have 3. We completed the square, so this is x plus 2 squared, and then minus 4. Now it's in work form. We know it's going to be steeper. We know it's going to be left 2 and down 4. So let's go left 2, down 4. There's the vertex. we pick points close to -2. So let's try -1 and 0. Just want to remind you, you can put that -1 and 0 back in here or back in our work form. Either is fine. Let's put the -1 here. -1 plus 2 is 1. Squared is still 1. 3 times 1 is 3, minus 4 is -1. So we should have the point -1, -1. Since parabolas are symmetric, we'll have another point over here at -3, -1. Plugging in 0, we could put it into this form, but it's actually easiest to plug 0 back into the original, because you'll have 3 times 0 squared, which is 0, plus 12 times 0, which is 0, plus 8. And so you just get 8, 0, 8, and because of the symmetry, we have another one over here. And now we're going to go ahead and graph this parabola. We're going to attempt graphing this parabola. Well, it doesn't get much more beautiful than that. Best parabola ever graphed.